Welcome back to my channel. In today's video, I'll be discussing about the function 1 by x power 2n minus 1. It is a generalization of the functions of type 1 by x. So let me show you. So this is the general form of the function y equals to x power 2n minus 1. Now this n belongs to the set of integers which is z. Okay, so this function has the exactly same property as the function y equals to 1 by x, this one. Okay, now for different values of n, which is this quantity here, we will obtain different functions. For example, here we can see that for n equals to 1, we get the function y equals to 1 by x. For n equals to 2, if we put here 2, then we will get 2 into 2 minus 1, that is 3. So it gives this function y equals to 1 by x cube. Similarly, for n equals to 3, we get the function y equals to 1 by x power 5 and so on. So we get these powers 1, 3, 5, 7, 9, 11 and so on. That is the odd integers. Okay. Now this function, this y equals to 1 by x power 2n minus 1 function has the exactly same properties as y equals to 1 by x, as I have already stated. So please check out my video on y equals to 1 by x to understand the detailed properties of this function here. Now moving to, we get 4 different regions in the real line such that the functions 1 by x, 1 by x cube, 1 by x power 5 follows different kinds of inequality. So let me show. Suppose this one is the real line. So we can divide it into 4 parts, this and this. So there is this part which is minus infinity to minus 1. Next, there is this part which is minus 1 to 0. Next, there is this part which is 0 to 1. And lastly, here it is 1 to infinity. So let us now understand how these functions behave in different regions. So let me start with this region which is 1 to infinity. So here we can see that for x greater than 1, this inequality holds. So let me show you with an example. Suppose if we take this x equals to 2. So obviously this satisfies this condition greater than 1. So what we will get, if we take the reciprocal here, we will get 1 by 2, 1 by 2 cube, 1 by 2 power 5 and so on. So obviously we know that 1 by 2 is greater than 1 by 2 cube and it is again greater than 1 by 2 power 5 and so on. So this inequality is true here. Let us now come to the next part, which is this part 0 to 1. So again we can check it by using an example. So suppose we take an example x equals to half. So obviously this half lies in the interval 0 to 1. So what happens if we take the reciprocal, we will get 2. So again 2 is not less than 2 cube. Okay, so this is not less than. So let me first write down it. 2, 2 cube, 2 power 5 and so on. So here we can see that 2 cube is 8 and 2 power 5 is much larger number. So here this inequality holds. So obviously this inequality is true in the region 0 to 1. Next, let us come to the interval minus 1 to 0. Which is this interval? This means this part here, minus 1 to 0. So again, if we check it with an example, what we will get? We will get that x equals to, suppose, minus half. Okay. So for minus half, if we take again the reciprocal, what we will get? Minus 2. Here we will get minus 2 cube, and as it is the odd power, so minus will be outside. Again we get minus 2 power 5, and from here it is obvious that minus 2 is greater than minus 2 cube, it is greater than minus 2 power 5, and so on. So in this region, this inequality holds for any number. Next, let us come to this region, which is x less than minus 1. What is this region? This is this part, that is minus infinity to minus 1. What happens here, if we check it with an example, we will see that, let me take an example. So for x less than minus 1, we might take it as minus 2. So if we take the reciprocal, what it will give? It will give minus half. It is again minus half cube. Why the minus is outside? Because it's again the odd power. And again here we have minus 1 by 2 power 5. So again it is obvious that minus 2 is less than this, So what is this? This one is actually minus 1 by 8. So if we consider the real line, here it is 0. Suppose here it is minus 1 by 2, then minus 1 by 8 will be nearer to 0. So obviously minus 1 by 2 cube is greater than minus 1 by 2, and hence this inequality holds in the region minus 1 less than minus 1 region. So if we try to plot the functions, we will get this kind of shape. So as I have already mentioned that, please check out my video on y equals to 1 by x. So there we can see that this black curve, if we consider the black curve, so let me write it down. The black curve is the 1 by x curve. Okay. So for 1 by x, we have already known the property, and these other curves, they all satisfy the same kind of properties, except that for different regions like this one, the 1 by x curve lies above the other ones. However, in this region, the 1 by x curve lies below. Again, here 1 by x curve lies above, and this region is where the 1 by x curve again lies below the other curves. So, the black curves is the 1 by x. Next is the blue curve, which is 1 by x cube. Next is the purple curve, which is 1 by x power 5. And lastly, the red curve, which is 1 by x power 7. So, different powers, different odd powers of 1 by x. Okay, so this is not actually minus, this is the representation, and here it is the representation, and similarly these are the representation only, not minus. Okay, so let us now check different intervals. For x greater than 1, that is 1 to infinity, this interval, what happens? 1 by x is higher, so 1 by x is greater than 1 by x cube, greater than 1 by x power 5, greater than 1 by x power 7. So let us now check the example or the condition. Here obviously 1 by x is greater than other curves. Now let us check the middle interval, which is this one here. Here we can see that 1 by x is actually lower, and the red curve, which is 1 by x power 7, is at the highest position. So here we can see that 1 by x is the least, and here from the condition it is obvious that 1 by x is the least among them. For the next interval, from this condition we can say that 1 by x must be highest, and here in the curve or in the graph, again we can see that in this interval, which is minus 1 to 0, The black curve is at the highest position and the red curve is at the lowest position. And the opposite one holds in the interval this, which is minus infinity to minus 1. Here, red curve is at the top and the black curve is at the bottom. So, again, the red curve, which should be somewhere here, is at the top and the black curve is at the bottom. So, these are the graph of the general function which has the form 1 by x power 2n minus 1. So, if this kind of graph given, I hope you can plot these graphs, and in the next video, I'll be discussing about another general kind of graph which is 1 by x power 2n. Thank you for watching this video. Please like and comment on this video and subscribe to my YouTube channel. Thank you.